I hope you got the idea about question A. So let let's start question B. But let me write the answer here. So this is going to be minus 16. So for question B, they asked me to find out the cube root of this expression and write it in standard form. That's meaning complex number standard form. So let's which means that this expression is the cube of a complex number. That means I need to write it down in this form, a plus bi. So that means I have r cubed equal 27 cosine pi minus I plus I sine pi. So first let me change this one to standard form first. So this become r cubed equal 27 cosine of pi is minus 1. Sine of pi is 0, so it's going to be just minus 1, so r cubed equal minus 27. So don't move to that steps and do the cube root. So if you do the cube root both sides, you end up having r equal minus 3, and in that case you will not find the complex solution. So what you do here is move 27 on the other side and factor. So here I will do r cubed plus 27 equals 0. Then I'm going to use this as the same thing as r cubed plus 3 cubed equals 0. So you're going to factor a cubed plus b cubed, which is the same thing as a plus b times a squared minus ab plus b squared. So this is the formula I'm going to use. So this is my a, this is my b, so it's going to be r plus 3 times a squared, which is r squared minus 3r plus 3 squared, which is 9, equals 0. Now the product of two numbers is 0 if one of them is 0, so I'm going to make the first one equal 0 or the second one equal 0. So the first one is linear, so it's easy to get. So r is minus 3, so I just minus 3 both sides. So my first real is minus 3. The second one is quadratic. I just need to use quadratic formula. So r will be minus 3. So I use the minus b plus or minus square root of b squared minus 4ac over 2a. So this is what I'm going to use. So minus b minus plus or minus b squared minus 4ac over 2a. So here my a is 1, b is minus 3, and c is 9. So a, b, c. So here I'm going to get my answer. R is minus 3 is 3 plus or minus square root of 9 minus 4 times 9 is 36 over 2a, which is 2. So which means I will have r equal 3 plus or minus square root of minus 27 over 2, which is the same thing as r plus 3 plus or minus square root of 27i. So for these steps, what we have square root of minus 27 is the same thing as square root of minus 1 times square root of 27. So this is I. So we just substitute this here. Now to write it in standard form, so I will have r will be 3 half plus or minus square root of 27 over 2i. So I have two solutions. So here the second one, it will be 3 half plus square root of 27 over 2i, and the last one will be 3 half minus square root of 27 over 2. If you have to simplify more, so you need to simplify 27, which is going to be 3 square root of 3, because 27 is 9 times 3. So that's the idea. So I hope this is clear. So let's move to the next question. So here they give me an expression or an equations, and they ask me to write it down into standard form. So that means this is a conic equation, so I need to see what type of conic I have, either parabola, hyperbola, or ellipse, or circle. So let's simplify this. So I have 4x squared plus y squared plus 24x minus 2y plus 21 equals 0. So I will try to get all the x together and all the y together. The number I will move it to the other side and try to create a perfect square with x and a perfect square with y. So that's my objective. So it's going to be 4x squared plus 24x plus y squared minus 2y equal minus 21. So here I have first common factor, so I'm going to take first common factor, x squared plus 6x. So here I will have minus 2y, so I'm going to add half of the middle terms and make a square on both sides. And I do the same thing here. I will add half of the middle number and make a square and put it on both sides, but I don't forget to multiply by 4, so it's going to be 4 times x squared plus 6x plus 6 over 2 square plus y squared minus 2y plus 1, which is equal to minus 21 plus 1. And here I will add 4 times 6 over 2 square. So this is my perfect square, so it's going to be 4 times x, the middle sign is positive, so I'm going to put it here, and I put 6 over 2, which is 3, then I put square, plus, and here I will have y minus 1 square, because the middle sign is minus. I'll put the middle sign, and this, I put this one here, 2 over 2 is 1, so, and here I will have minus 21 plus 1, and this is 9 times 4 is 36, so it's going to be plus 36. So here I will end up having 16, because minus 21 plus 1 is minus 20, plus 36 is 16, and here I will have 4 times x plus 3 square plus y minus 1 square. So here I divide the whole thing by 16 because I have a coefficient here. If I have no coefficient here, that means I will end up having a circle. But if I have a coefficient here or here, we divide by the term after equal sign. So in that case, we'll end up having an ellipse or hyperbola based on the sign of the middle. So if I have minus here, it's going to be hyperbola. But if it's positive, so it will be an ellipse. So I divide here by 16 and here divide by 16. So my answer will be x plus 3 squared over 4, which is 2 square, plus y minus 1 square over 16 equal 1. So this is the form of ellipse. So this is an ellipse. So to find out the center of the ellipse, I just make this term equal 0. So x plus 3 equals 0. I will have x equal minus 3. And I make y minus 1 equal 0. I will have y equal 1. So center is minus 3, 1. Now, because the y fraction or the y denominator is greater, that means the ellipse will look like this. So that means we have two vertices. So we have vertices here and we have vertices here, and if this is the center, so this is my point minus 3, 1. That means this is the vertical, that means it involves the y coordinate. So if this is 16, the square root is 4, so I'm going to add 4 here and minus 4 here, because this is the down is the negative and the up is the positive. So I will add on the y coordinate here, I will add 4 and I subtract 4, so this means I will have minus 3, minus 3. So this is the coordinate of the first vertex, and here will be minus 3, 5, and this is the coordinate of the second vertex. So the vertices have coordinate minus 3, 5 and minus 3, 3. So this is the answer for that question. So if we have minus here, it will be hyperbola. But if there is no coefficient here, for example, it was no coefficient here, and we have only that expression equals something here, so we got the equation of a circle. So that's the idea of that question. Alright, for here they give me a quadratic equations, but in order for me to see it as a quadratic equations, I need to substitute u by cosine x, or cosine x by u. So here I will end up having u squared minus 3u plus 1 equal 0. So in that case it's simple to deal with, because this looks like the same type of quadratic we used to do before. So here what we do, we use quadratic formula. So u will be minus b, which is 3, plus or minus square root of b squared, which is going to be 9 minus 4 times 1 over 2, because a is 1 here. So which is give me here 3 plus or minus square root of 5 over 2. Then what I do next, I substitute u by my expression. So cosine of x equal 3 plus square root of 5 over 2, and cosine of x will be 3 minus square root of 5 over 2. So if I approximate this, I will have 3 plus 2 point something. So it's gonna be around like it's gonna be 9 divided by 4 is 2.25, so just an approximation, over 2. So it's gonna be 5.25 over 2, which is the same thing as 2.625. This is greater than 1. That means this is not part of the solution, because we know that cosine is always between 1 and minus 1. So be careful with that case. So always check the number if it's greater than 1 or less than minus 1. If it was like, for example, minus 2.6, I will not take it because it's below minus 1. So for that one, so obviously it will work. Why? Because this is going to be almost 3 minus 2.25 over 2, which is the same thing as 0.75 over 2, and this is less than 1, obviously. So but I will not work with this, I will work with that one. So now if I have cosine x equal an expression that's very hard to evaluate, so what we will use the cosine inverse. So here I will have x will be cosine inverse of that expression, then plus 360k. And if we use the positive angle, we're going to use the negative angle as a second choice. So minus cosine inverse of 3 minus square root of 5 over 2 plus 360k. But here they want the answer between 0 and 360. This is all the answer. K is integer, can be positive, can be negative. But here they want between 0 and 360, so I'm going to choose k equals 0 and k equal 1 to see which one will work for me. So for k equals 0, I will have this angle. So for k equals 0, I will have this x equal cosine inverse of 3 minus square root of 5 over 2. So if you use the calculator, you will end up having you will have a almost 68 degree. If I use k equals 0 here, it's going to be negative, but they want a positive angle, so I'm going to choose the k0 here. So now I'm going to do for k equal 1. If I put k equal 1 here, it's going to be greater than 360, because I will have 360 plus an angle. So I will not use k equal 1 for that case here, but I will use k equal 1 for that one. So here I will have x equal 360 minus cosine inverse of 3 minus square root of 5 over 2, and this will give me an approximation of 292 degree. So I hope you got the idea here. So let's move to the next question. Here they give me polar coordinate equations, and they want to find out the rectangular equations. So they want an equation in terms of x and y. So the only relation I know about the polar coordinate and the rectangular coordinate is that x is r cos theta, y is r sine theta, and x squared plus y squared is r squared. Plus, in terms of tangent, we know that tangent of theta is y over x. So those are the only information I have. So I'm going to use those to change this one from polar to Cartesian coordinate or rectangular coordinate. So r equal 3 1 plus cosine theta, so multiply both sides by cosine theta, r times 1 plus cos theta equal 3. So distribute the r plus r cos theta equal 3. Now I know that this is my x, so I'm going to substitute this one by x, but I cannot keep the x and r on the same side, so I need to move the x on the other side. R equal 3 minus x. Why don't move r on the other side? Look, I'm looking for something related with x. That means I need to solve for r. So if I'm looking for something related with the r, I'm going to solve for x, because I'm looking for eliminating the r, so I'm going to solve for r. Now what I do here, I square both sides, because if I square both sides, I will end up having this expression, which is something related with x and y. But if I don't square both sides, or I multiply both sides by r, I will have r here again and r square here. That means I didn't do nothing. So what I do here, I square both sides is better. So that means here I will have x squared plus y squared equal 3 minus x squared. So I'm going to fold this. When we fold, we don't distribute the square, we fold. That means I will have 3 minus x times 3 minus x. So this is what we do here. We'll end up having 9 minus 6x plus x squared. So I'm gonna minus x squared together. So I got y squared equal 9 minus 6x. And here I need to, this look like parabola. So this is going to be a horizontal parabola, something that look like this, either this one this way, either facing right or facing left. So let me see which one I have here, but I need to write it down in the right form. So let me have some space here. Alright, so the only true form I know is either y squared equal 4 times a constant x minus a, or I can have x squared equal 4 times a constant y minus b or a, whatever. So I need to have this, but I have the first one, so I need to make sure that I create a constant here times x minus another number. So here the only common factor here I have, which is the coefficient of x, is minus 6. So I will take minus 6 as the common factor. I'm going to be minus 6 times x minus 9 over 6. So this is my common factor. So I will have y squared equal minus 6 times x minus 3/2 as amplify. So here will tell me the location of the vertex. So the vertex here is gonna be, because here this is 0, I make this one 0, I make this one 0, so the vertex here will be 3/2 0, so I make this one equal 0 and I make this one equal 0, so y squared equals 0, y equals 0 is 0, so then we have x minus 3/2 equals 0, that means we'll have x equals 3/2. So this is the coordinate of the vertex. Now they ask me for the focus. So for the focus I need to find out this value f and add it to that one. So here I know that for f will be equal minus 6. That means my f is minus 6 over 4, which is minus 3/2. So the parabola is look like this. So let me show you the idea. So the parabola look like this. So this is gonna be my 3/2, which is my vertex. So it's gonna look like this way. So the directrix is on that side, which is the same thing as you add 3/2 to this one, so it's going to be, this is 3/2, so the axis will be x equal 3/2 plus 3/2, which is f plus f. In fact, is minus is minus f, but f is minus 3/2, so it's exactly what we do here. So it's going to be at 3, and the focus is you add f to the x, which is the value where the vertex is, which is the x coordinate. So you add minus 3/2 here, so it's going to be here. So the focus will be focus will be 3/2. I'm gonna add f to the 3/2, so it's gonna be minus 3/2, 0. So it's gonna be 0, 0. So this is the location of the focus. So like I say here, this is the parabola, and this is the vertex of the parabola, and this is the focus of the parabola. So the vertex, we just make the y equals 0 and make the x equals 0. If I have y minus 2, it's going to be y minus 2 equals 0. So you solve for y, you make x equals 0, you solve for x. Then to find out the focus, you just take, you need to find out the value of f. Just keep in mind, for f will be equal to that expression or that number here. Then what you do here, you add the value of f to the here it's horizontal, that means you add it to the x value. If it's vertical, you add it to the y value. So it depends what type of parabola you have. If you have horizontal parabola, so you add that value, which is the f, to the x coordinate of the vertex. If you have a vertical parabola, that means look like this, so you add the f value to the y coordinate of the vertex, and this you will find out the focus of the parabola. So I hope it's clear. So last question. So here they ask me to check if this identity is true. So I'm going to start with this 1 plus sine x over 1 minus sine x minus 1 minus sine x over 1 plus sine x. So I make common denominators. I'm going to try this one by this here and multiply the denominator together. So it's going to be 1 plus sine x square minus 1 minus sine x square over 1 minus sine x times 1 plus sine x, and this will give me 1 plus 2 sine x plus sine square x minus parentheses 1 minus 2 sine x plus sine square x over, this is a minus b times a plus b, that means I will have 1 minus sine square x, and this is cosine square x. So here is going to be 1 plus 2 sine x plus sine square x. I distribute the minus sine square x over 1 minus sine square x. So here I simplify the 1 here, this, and this will be cosine square, so it's going to be 4 sine x over cosine square x, which is the same thing as 4 times sine x over cosine x times 1 over cosine x. This is tangent and this is secant, so it's going to be 4 tangent x times secant x, and you can switch them because multiplication is commutative, so it's going to be 4 secant x times tangent x, and that's all. So I hope you have a good review, and I hope it's helped. So please, if you have any comment about the way I present, so do so, it will help me a lot. Thank you for watching the video, and Assalamu alaikum.